Video. This is the video which is continuation to carbocation. So what is the topic? Reaction intermediates. Reaction intermediates are mainly three types. Of course there are 6 reaction intermediates: carbocation, carbanion, carbon free radical, carbenes, nitrines, benzenes. But we will discuss only carbocations, carbanions, carbon free radicals, which are present in main syllabus and NEET MCET syllabus. In that first one is carbocation. So in previous video carbocation explained in some portion. So how carbocation is formed, carbocation stability, factors affecting on stability of carbocation, and next rearrangement of carbocation. This is continuation to that. That is ring expansion and ring compression. Those are also stability, rearrangement of carbocation to become stable. So whenever if there is a possibility to rearrange carbocation from less stable to more stable, that is possible. In case of carbocation, in carbon free radical also both are possible. Okay, in first ring expansion, we know carbocation stability, as we know stability of carbocation. What are carbocation? The reaction intermediate in which carbon carrying positive charge. Carbocations are also called as carbonium ions. Tertiary carbocations are more stable than secondary carbocation, which are more stable than primary carbocation. Primary carbocation is more stable than super primary carbocation, that is methyl carbocation. Next, size of the with respect to size of ring in cyclocompounds. 6-membered rings are more stable compared to 5-membered rings, which are more stable compared to 7-membered rings, which are more stable compared to 4-membered ring, and finally 3-membered ring. 2-membered rings are not possible. At least 3 carbon atoms must be there. So based on Bayer's strain theory, Bayer's strain theory, 6-membered rings are more stable compared to 5-membered rings, which are more stable compared to 7-membered rings. Okay, right. So if carbocation is like this, on external carbon other than the cyclic chain carbon, this carbon has positive charge. In that case, what happens? In that case, it become, okay, this bond will become weak and this new bond formation takes place like this. So this is primary carbocation, primary. Okay, so now what happens here? This is bond breaking, and this is what bond formation, new bond formation takes place. That it gives what new bond formation completely takes place. This is intermediate, some transition state here. For understanding purpose, I have written. Okay, so now this bond shifted to here. This carbon become positive because this carbon lost this bond pair. Complete shift of bond pair from here to here takes place. That's why this carbon definitely become positive. What is this? This is nothing but what? 4-membered ring with positive charge. So this is what secondary carbocation or not secondary carbocation, which is more stable. Some less stable to more stable. This is primary, less stable compared to this secondary, which is more stable carbocation. Thus less stable carbocations rearranges to more stable carbocation. Next, if 4-membered ring with positive charge is like this. This undergo rearrangement. I am writing directly like this. Okay, sorry, due to loss of bond pair, this carbon become positive. This is nothing but what? 5-membered ring, pentagonal with positive charge. Okay, this one. Next, take this one. Right, next, pentagonal here contain positive charge. So then it become what? This bond will break here and here new bond formation takes place. This bond break, this new bond formation takes place. Here carbon carrying positive charge. 1, 2, 3, 4, 5, 6. 6-membered ring with positive charge like this. If you see here, this is what? Primary carbocation. This is primary carbocation. This is secondary carbocation. So some less stable to more stable rearrangement takes place. So write, next take one question. If question is like this, write the product of the following reaction. Write product of following reaction is question. Write product of following reaction. Write product of following reaction. And the question is like this. Here bromine in presence of aqueous silver nitrate, what will be the product? They will give option, but I do not. Okay, see, product is like this. Pentagonal ring, here bromine is there. First of all, we must aware of aqueous silver nitrate solution. In aqueous silver nitrate solution, what are present? Aqueous means H plus ion, OH minus ion, silver nitrate, Ag plus ion, and NO3 minus ion. Okay, this H plus combines with nitrate and become HNO3. This Ag attract Br minus, then it become what? Production of carbocation. That is our valid point. Okay, here Ag Br formation takes place. Bromine along with bond pair Br minus. This carbon become positive. So now ring expansion takes place like this. This is some primary carbon. So the ring expansion takes place. 5-membered ring. Next, this is the expected one. Okay, and here what? Like this. This bond comes here. Okay, nothing difference, only this bond break and this new bond formation takes place. And shift of this is what? 1, 2, 3, 4, 5, 6-membered ring. This is up equals to what? 6-membered ring. On one carbon positive charge, on other carbon methyl group. This is methyl group. Now shift of hydrogen takes place from here, because this is what? Secondary carbocation, which rearranges to tertiary carbocation by the shift of hydrogen. This become positive. Hydrogen shift here 1, 2, H minus shift. In previous video we have discussed many examples. Now after that, this Br minus addition, sorry, OH minus addition takes place. This OH minus attack here. Due to attack of this OH minus, that become here or here, any position, both are same, bromine. This is the product. That means 5-membered ring become 6-membered ring. Ring expansion takes place. In this example, we have to remember ring expansion takes place. Carbocation intermediate means ring expansion. If ring expansion possible, that will take place. Okay, take this one. Next, ring contraction. Similar to ring expansion, ring contraction. If cyclic chain carbon containing positive charge, cyclic chain carbon containing positive charge, okay, here this bond breaking takes place. Okay, this new bond formation. Okay, this bond breaking takes place. This new bond formation. Here what? Bond formation. Here bond breaking. That due to shift of complete this bond pair towards it, this carbon become positive. That's my point. This is positive. Okay, next, the shift of hydrogen takes place to here to here. This is secondary. If hydrogen shifted here, this hydrogen shift here, shift of hydrogen, here what? 1, 2, H minus shift, 1, 2 H minus shift, then this carbon become positive. This is what? Tertiary. This is secondary. This is more stable. So this is more stable compared to this one, tertiary carbocation. So when will we expect ring expansion? Carbon atom, if carbon atom, ring expansion possible in ring expansion. So clue, ring expansion in compounds, ring expansion in molecule, in which carbocation outside of ring, but ring compression, ring contraction or ring compression, ring contraction in molecules in which carbocation present in the ring, out of ring expansion, present in the ring. This is carbocation which is present in the ring. Okay, cyclic membered carbon, then ring compression, we will expect ring compression. Okay, take one example. First of all, take this, I will give a question. What is the product of following reaction? What is the product of the following reaction? That is 7-membered ring. 1, 2, 3, 4, 5, 6, 7-membered ring. Here bromine. 7-membered ring with one bromine. Next here what? Aqueous silver nitrate. Aqueous silver nitrate, or otherwise like this. Some more rearrangements. To take more rearrangement, I have taken like this. So for this reaction, aqueous silver nitrate take Br minus and provide OH minus. So aqueous means H plus OH minus Ag plus ion and NO3 minus ion, and remember always HNO3. So this Br minus takes attracted by Ag plus, and OH attack takes place here. OH comes here, but between leaving of Br minus ion and attacking of OH minus, carbocation formation takes place, and that carbocation undergo rearrangement. See, this carbon carrying positive charge. Next, ring expansion takes place. Ring compression takes place here. Ring compression. Just understand ring compression. Like this. Okay, this is what? This is bond breaking, BB, and this is what? Bond formation. This bond comes here. That means this carbon become positive. So that leads to here a 6-membered ring. Yes, this is 6-membered ring. Here what? This is positive charge, like this. Okay. That is carbon. Which carbon? Tertiary carbon, on which OH minus attack takes place. Then I am taking this 6-membered ring like this. Okay, and one of the carbon, this one, like this, and OH attack here. This is what? This is secondary, and it become tertiary. Tertiary alcohol will be the product, and 7-membered ring unstable, it become 6-membered ring, stability. So this becomes stable. If OH minus attack takes place, that is secondary, and 7-membered ring unstable. So this is what? Here this is 7-membered ring. 7-membered ring. 1 point, secondary carbocation. Secondary carbocation. This is another point. Both are unfavorable. But if you see here, due to this rearrangement, what happened? This becomes 6-membered. One advantage, 6-membered, and become tertiary carbocation. Tertiary carbocation. This is second advantage. So due to these two reasons, this is some less stable carbocation intermediate rearranges to more stable carbocation. So this one takes place. Thus rearrangement takes place. This rearrangement is called ring contraction. From here to here, this is all this is what? Ring contraction rearrangement. Ring contraction rearrangement. Ring contraction takes place. Ring expansion, ring compressions takes place in case of carbocation, carbon free radical. Ring contraction, ring expansion, rearrangement reaction, all are possible in carbocation and carbon free radical. Remember that point. Okay, take this one. Second reaction intermediate, that is carbene ion. What is carbene ion? in reaction intermediate, second reaction intermediate is carbene ion. What is carbene ion? It is reaction intermediate. It is reaction intermediate. It is reaction intermediate in which carbon carrying negative charge. In which carbon carrying negative charge. It is the reaction intermediate in which carbon carrying negative charge. Okay, right. So for example, this is some molecule. If electronegativity of carbon is greater than Z, then what happens? If electronegativity of carbon is greater than Z, then so carbon takes bond pair electron. Carbon takes bond pair electron and become Z, and it becomes Z plus. This is carbon ion. This is what? Carbon ion. Okay. In this carbon ion, carbon carrying negative charge. Next, what is hybridization of carbon? Hybridization of carbon. Hybridization of carbon. Hybridization of carbon in carbon ion is hybridization of carbon in carbon ion is sp3, and shape is tetrahedral, and shape is what? Tetrahedral. Okay, right. Carbon ion shape is like this. This is negative charge here. This is carbon ion, negative charge carried by negative charge. Okay, right. Carbon ion is nucleophilic in nature. It has 8 electrons. So it is electron rich. Carbon ion is electron rich in nature. Electron rich in nature. It has octet configuration. Octet configuration. Even though it has octet configuration, it is unstable because of negative charge. So 8 electrons are there. If 8 electrons are present, that is stable actually, but due to presence of negative charge, it is unstable. Carbon ion is unstable even though carbon ion is unstable. Even though carbon ion is unstable. And carbon ion is nucleophilic in nature. Carbon ion is nucleophilic in nature. Nucleophilic in nature. Carbon ion is nucleophilic in nature. Okay. Take these points. Carbon ion is diamagnetic in nature due to presence of octet configuration. Carbon ion is diamagnetic in nature. Carbon ion is diamagnetic in nature. It has octet configuration. All electrons are paired up. So diamagnetic in nature. Next, carbon ion formed as reaction intermediate. Reaction intermediate in addition reactions of addition reactions by RMGX or Grignard reagent. RMGX is called Grignard reagent. Grignard reagent. This is what Grignard reagent. Okay, we will see later. Second one, Beckmann reaction. Beckmann's reaction. Third one, Cannizzaro reaction. Cannizzaro reaction. Carbene ion act as intermediate in Cannizzaro reaction. And fourth one, E1CB, elimination of conjugate base reaction. In these four reactions, importantly, carbon ion act as intermediate. If you talk about stability of carbon ion, carbon ion is stabilized by resonance, and minus I effect. Carbocation stabilized by plus I effect. Carbon ion stabilized by minus I effect. Example, if you see CH3 minus and CH3 CH2 minus and CH3 CH3 and finally CH3 and this is CH3 minus. But among these four, which one is more stable? Among these four, this is more stable than second one, more stable than third one, then fourth one. This is just super primary. This is primary. This is secondary. This is tertiary. Reason: hydrogens are neutral. Your methyl group is what? Plus I group. So minus I effect stabilizes, plus I effect destabilizes carbon ion. Here, how many plus I groups? 2 plus I groups. Both sides plus I groups, very unstable. 3 sides plus I groups, very, very unstable. That means we have to know that minus I group increase stability of carbon ion, plus I group decreases plus I effect decreases stability of carbon ion. Okay, so carbon ions are stabilized by minus I effect, destabilized by plus I effect. Carbon ion stabilized by resonance and minus M effect. Carbon ions are stabilized by minus M effect. Destabilized by plus M effect. So remember this. I will give some example. First take this one. Right, see these questions. Write stability order of following carbon ion. So in question 1, 3 carbon ions are given. Which one is more stable? So if you see this one, in first one, resonance is possible. Negative charge and double bond are in conjugation. So negative charge, single bond, double bond. So resonance is possible. So it is stable. Here this is plus I effect. Plus I effect actually destabilize carbon ion, very, very unstable. 3 hydrogens are neutral. So this is neutral. That's why which one is more stable? So definitely A more stable than B more stable than A more stable than, C more stable than B. B is very, very unstable due to plus I effect. Minus I groups stabilizes carbon ion, plus I groups destabilize carbon ion. So if you see question number 2, resonance is not possible, minus I effect. This is sp2 carbon, sp carbon. Okay, so based on this is which carbon? Carbon ions are sp3 carbons. This is carbon ion, but double bond, single bond, double bond, with hydrogen single bond or double bond, sigma sigma lone pair, don't count pi. So in double bonded carbons are sp2, remember that one first. Triple bonded carbons are sp. Electronegativity of carbon, sp carbon more electronegative than sp2 carbon, more electronegative than sp3 carbon. More electronegative species with negative charge more stable. More electronegative species, are atom, more electronegative species with negative charge more stable, more stable. So which one is more stable? Definitely C more stable than, B more stable than A, because sp3 carbon with negative, sp2 carbon with negative, sp carbon with negative. Sp carbon is more electronegative with negative charge is more stable. Remember that point. Next here, negative charge stabilized by resonance here, like this, resonance possible, resonance is possible. Here also resonance possible, here also resonance possible. Okay, here also resonance possible. Here what is present? Nothing. Hydrogen means neutral. Okay, hydrogen resonance possible. Hydrogen neutral. Here NO2 group is what? Minus M group. Strong minus M group. CHO group. This is also minus M group, but weak minus M group. Compared to nitro group, aldo group is weak minus M group. Here OH group is plus M group, plus M effect. So anions are stabilized by, carbon ions stabilized by minus M effect, destabilized by plus M effect, neutral better than even plus M effect. So which one is more stable? Strong minus I group more stabilizes carbon ion, B more stable compared to next weak minus M group. C, this is C, not E, C. C more stable than, plus M group destabilizes, neutral better than this one. So A more stable than D. D very, very unstable due to plus M effect. Plus M plus I effect decreases stability of carbon ion, increases stability of carbocation. Next here OCH3 group. This is what? Plus M group. This is plus I group. Methyl group is plus I group. Chlorine group is plus M and minus I, but minus I dominated over plus M. For only halogen, in general, mesomeric effect always dominated over inductive effect. For only halogen, inductive effect dominated over mesomeric effect. Halogens are minus I groups and plus M groups. Minus I and plus M group, but inductive effect dominated over mesomeric. Consider only inductive effect for it. So between these four, which one is more stable? So you know, minus I groups stabilizes carbon ion. So definitely C more stable than. Between plus M plus I, which one is stronger? This is stronger, this is weaker. So weak plus I is unfavorable, plus M is also unfavorable. Weak unfavorable is better than strong unfavorable. Thus we write stability of carbon ion. Take this one. Next, stability of carbon free radical. I will explain stability of carbon free radical. First take this one. third reaction intermediate, that is carbon free radical. Carbon free radical is third reaction intermediate. What is the carbon free radical? It is the reaction intermediate. It is the reaction intermediate. It is the reaction intermediate in which carbon carrying unpaired electron. So carbon free radical, it is formed by homolytic bond fission. These are formed in free radical reaction, homolytic bond fission. So for example, this is a bond, some Z or X or anything, take anything, some X, I am taking X, or some Z, I am taking some Z. If electronegativity of carbon is equals to X, then what happens? Then homolytic bond fission takes place. Both carbon and halogen separated with one electron. Thus, this carbon with one electron and X with one electron. Free radicals are formed. These two are what? Free radical. In that, first one is carbon free radical. Carbon free radical has septate configuration. Carbon free radical has septate of electronic configuration. So carbocation 3 bonds, 3 to the 6 electron. Sextate configuration. Carbon free radical 3 to the 6 plus 1, 7 electron. 7 electron means septate electronic configuration. How many electrons? Septate means 7 electron, having 7 electron. So if you see carbene ion 2 plus 2 plus 2. Anion means, this means this is also 2 electron. Total octet config, 8 electron. Octet, 8 electron. Okay. Carbocation, carbon free radical, and carbene ion. Carbon free radical has septate of electronic configuration. That's my point. Next, carbon free radical is electron deficient. Carbon free radical is electrophilic in nature. Carbon free radical is electrophilic in nature. What about carbocation? Carbocation is electrophilic in nature. Electrophilic. Carbon free radical is also electrophilic in nature, electrophile. And carbocation is electrophile, carbon free radical electrophile. Carbene ion is nucleophile. Remember that point. So here carbon hybridization in carbocation, carbon hybridization is sp2. In carbon free radical, carbon hybridization sp2. In carbene ion, carbon hybridization sp3. Only in carbene ion, carbon hybridization is sp3. So this is information you have to remember. So when you talk about shape, what is shape of carbene ion? Trigonal planar. Its shape is what? Trigonal planar. Carbene ion shape is tetrahedral. Pyramidal. Carbene ion shape is pyramidal. shape of carbon ion is pyramidal. Okay, so carbon free radical, it has two shapes, that is important. Two shapes are there. One is trigonal planar and tetrahedral also, both are present. So see that one, how is it possible? Write that point. Carbon free radical, in carbon free radical, hybridization of carbon is sp2. sp2 acts as electron deficient species. Okay, and the shape of the molecule. So to write shape of molecule, so we need to remember one. First take this one, I will explain shapes. Let's see about shape of carbon free radical has trigonal planar shape. Carbon free radical has which shape? Trigonal planar shape, except CX3 halogens, whenever 3 halogens are present. Example, CH3. Which shape? Trigonal. Here it has trigonal planar shape. CX3. Here it carbon free radical has lone pair. So not lone pair, unpaired electron, like this. Here this with electron. This is also with electron here. This is not different, this is also same. Okay. Here 3 bonds are in the plane, so trigonal planar. Here 3 bonds are not in the same plane. That is what? Pyramidal shape. This is pyramidal, which has pyramidal shape. Okay, so all carbon free radicals are trigonal planar. If halogens are present, that become pyramidal, because each halogen contains 3 lone pairs. Those halogens contain what? 3 lone pairs. Each halogens contain 1 bond and 3 lone pairs. So due to repulsion between lone pair electrons of halogen and this unpaired electron, repulsion between unpaired electron of carbon with halogen, so those bonds push it to down. So like this bond push it to down. That's why that has which shape? Pyramidal shape. So all those carbon, hydrogen, all in the same plane possible. But carbon with halogen, this unpaired electron of carbon repel with lone pair electrons of halogen, then 3 lone pair electrons comes down, that the shape become pyramidal. Okay, hope you understood. take this one. I will give some questions. Write the stability order of the following. Question is, write the stability order of following carbon ions. So in that first one, this is A, for example, and this is B, and the next one, this is C. Which one is more stable? So I want to write one point, that carbon free radicals are stabilized by carbon free radical stability similar to carbocation stability. Carbon free radical stability is similar to carbocation stability. That means stability directly proportional to resonance plus I effect plus M effect. Inversely proportional to minus M effect to minus I effect. So that is the point. Similar to carbocation mean, so carbocation stabilized by plus I group plus M group resonance. Carbocation destabilized by minus I group minus M group. In the similar way, carbon free radical also. Okay, here for this carbon free radical, here this is the group, this is the group. This is which group? Plus I group, plus I group, plus I group, plus I group. So plus I groups are favorable. Here this is what plus I group, this is what plus I group, plus I group, plus I group, stable, and resonance is also possible. Resonance is also possible. So here only plus I effect. Here how many plus I effects? 2 plus I effects. Here 2 plus I effects. 2 plus I effects and resonance. Both stabilize. Here only plus I effect. Here plus I effect and resonance. Both stabilize carbon free radical. Here only resonance. Resonance and plus I effect both are present. Resonance and plus I effect. Only one plus I effect. One plus I effect. Now tell me which one is more stable. So 2 plus I resonance is definitely more stable. 2 plus I and resonance is definitely more stable than 2 plus I, 1 plus I, 1 resonance. C more stable than A. Hope you understood. Take this one. Next, see this one, stability of carbon free radical. Here carbon free radical stabilized by resonance. Homolytic bond fission takes place. Resonance. Here how many alpha hydrogen? This is alpha hydrogen, and this is resonance. 2 alpha hydrogen mean with free radical hyperconjugation effect or plus I effect. Both plus I hyperconjugation stabilizes, but hyperconjugation dominate over plus I effect. That we have to remember. And resonance also stabilizes. Hyperconjugation and resonance stabilizes this one. Here only hyperconjugation. So hyperconjugation stabilizes carbon free radical. So resonance here, resonance and hyperconjugation here only hyperconjugation. So domination, resonance always dominate over hyperconjugation, hyperconjugation dominate over inductive effect. That's why definitely which one is more stable? B free radical is more stable because of two hyperconjugations and resonance effect. Here only hyperconjugation, here resonance. So A more stable compared to C. Next, if you comes to this question, that is what stability of free radical. Here this is stabilized by resonance. The resonance is possible or not? Yes, resonance is possible. Here resonance with hyperconjugation. This offers hyperconjugation because double bond and alpha carbon hydrogen, 3 alpha hydrogen. 3 alpha hydrogen mean H effect. Hyperconjugation mean 3 alpha hydrogen with double bond, hyperconjugation. Here how many alpha hydrogen? 3 plus 3, 6 alpha hydrogen, 6 alpha hydrogen. Here how many alpha hydrogen? 3 alpha hydrogen. Here how many? So here not hyperconjugation is not possible. Now tell me here. So NO2 group is actually what? NO2 group is minus M group. So since this is minus M group, when multiple bond present between more electronegative atom, linking atom multiply bonded with more electronegative atom, that definitely act as what? Minus M group, strong minus M group, not weak, strong minus M group. And when lone pair electrons are present, that definitely plus M effect. Okay, so just like carbocation, carbon free radicals also stabilized by resonance, hyperconjugation, plus M effect, inductive effect. So which one is more stable? Only resonance. Here resonance with resonance is there on in all these three. Resonance is there. Resonance possible, resonance possible. Here also resonance is possible. But which one is more stable? All are resonance means resonance is not a criteria. Then neutral, hyperconjugation stabilizes, minus M destabilizes, plus M stabilizes. Which one is more stable? Therefore, which one is more stable? So in all these four, resonance is present. So resonance is not a criteria. Hyperconjugation, mesomeric, minus mesomeric, plus mesomeric effect. Definitely what? D is more stable because plus M groups stabilizes carbon free radical, carbocation, both. So next hyperconjugation, this one stabilized. B, minus M destabilizes, here neutral. So compared to negative effect, neutral is better. So A more stable than what? C. This is stability order. In this way, we write stability order of carbon free radical. With this, carbocation, carbanion, carbon free radicals are completed. This is about reaction intermediate. This is reaction intermediate. With this, reaction mechanism completed. So I divided reaction mechanism into two parts, reaction mechanism 1 and reaction mechanism 2. Reaction mechanism part 1 completed. In next we have reaction mechanism 2. In that where we will learn types of organic reaction, very important. Next in reaction mechanism 1, previous competitive bits I will do next video. Previous competitive bits on reaction mechanism 1 concepts, bond cleavages and types of reaction intermediates. Next what? Electron displacement effects. After that, types of attacking reagents, electrophiles, nucleophiles, free radical. So mesomeric effect, hyperconjugation, inductive effect, resonance effect, aromaticity, all these covered in reaction mechanism 1. This is very important and very basic for organic chemistry. Without this, it is not possible to understand organic chemistry. Okay, so in next video, previous competitive bits on reaction mechanism 1. Then after, I will give reaction mechanism 2, types of organic reaction. That is also very important. Okay, if you like this video, so please like this video, please comment this video, please share this video. So your comments, your likes boost me a lot. Okay, so if you give comments, if you like this video, so I can understand some people are following me, so I want to do some videos. Otherwise no following, no videos, so how can I do? Okay, so how long I will I continue this one? So please share. If you trust this one is useful for aspirants of MSET, mains and NEET, just give a suggestion. This channel, Ajay Chem Tube channel. Okay, thank you very much.